Hello, students. Welcome back. It is Mr. Campbell here. We are now entering our third week into our e-learning. Again, I know this is a little later in the day that I will be posting this in the afternoon, but hopefully with that being said, you guys have already started your assignment for the week, which if you guys can see here on my screen, I'm going to scroll down through EDSB. We have our moon phases lab, right? So the important updates I wanted to mention, rather than just having the go blue up right off the bat, was there will no longer be attendance polls. I've been informed by some of my colleagues and some of the administration that there are students who cannot access computer every single day of the week, even during the weekday, because parents need the computer, siblings need the computer. So again, just make sure, again, there won't be attendance polls, but do make sure you keep up with all the videos when your time permits. And keep up with those notes in those videos, and then get your assignments done by the end of each week, Saturday and Sunday, and you should be right on track with us academically on our e-learning. So assignments will no longer just be due on a Friday. They'll be due Saturday, Sunday. Get those done by the weekend. You'll start those on Monday. The quiz you'll start on Friday, and then you have all that done by Saturday, Sunday. You should be all set. Again, no later than Sunday late afternoon, and you should be good there. Okay, so yeah, be up to date with your YouTube lessons, get your work done by the end of each week, and you should be okay. If you have any questions, as always, let me know. As for our lab, again, notebook checks, you guys should have submitted those. Submit those if you haven't already. Let's see if I've got it down here. The moon phases lab, as you guys can see here, again, all you're going to do is, given you as the Earth and the position of these little circles here, the moon and the sun, what phase is the moon going to be? And this is something we're going to discuss hopefully later this week. But just to help you guys out, if you're really, really confused, I mean, it's one thing to search things online and find it, but just to help you guys out. Oh, let's see. I clicked on the sample here. I just wanted to get a visual of it, actually, not just load it. But you'll see here this chart, this diagram that I posted right here. Hopefully it's going to load. It's going to pop up. I guess not. Okay, well, it should pop. Oh, there we go. All right, use that chart. It should help you to understand the moons, how they appear based on the positioning of the Earth relative to the sun. So let's go ahead and go back. Make sure to watch the video along with that as well. Again, this is the lab. Again, our weekly assignment is a lab report, but I'm using the video for you guys to analyze it, as opposed to us doing it in class together in person, right? So if we look here, you can clearly see we've got a styrofoam kind of ball here on a stick with a light bulb. You could have had lamps and light bulbs in our lab to do this. And then take a look based on the positioning of your, again, that styrofoam ball is simulating the moon, right? It would determine what phase of the moon you will be in. And we'll learn about that in more detail later this week. But let's go ahead and check it out.
We know that the moon orbits the Earth. So in this model, I'm going to get the moon, the foam ball, to orbit the Earth, my head. Notice that no matter where the moon is in its orbit, half of it is always lit up by the sun. But when the moon is in this position, I can't see any of the lighted side of the moon from Earth, my head. From this angle, you can see what I am seeing from Earth.
So basically, she's going to walk you through step by step. You see the lighting change on the surface of that moon, how we get the different moon phases. So use that to analyze and complete your lab analysis there. Okay, let's get to our presentation, guys. I'm going to try and it's going to be longer than 15 minutes, obviously, because I explained the lab a little bit, the assignment of the week, but we'll continue to progress through as we always do. Okay, again, grades are currently being updated. They should be up to date within the next few days with your newest notebook checks and quizzes. The unit quiz number 3 will be on Friday as usual. No notebook check this week, and the lab will be due on Sunday afternoon. So all of this will be due no later than Sunday afternoon. The assignment is, you can access the assignment today as of this morning, and the quiz will be starting on Friday as usual. Our 3 questions, guys. Number 1 on page 6. What does Kepler's second law state? This is on page 5 from last week. Number 2, what does Kepler's third law state? And 3, what is a planet's perihelion? Pause the video, take a moment to think and write this out. Answers are going to include number 1, planet for the second law of Kepler's laws on planetary orbit. Planet's orbital speed increases as a planet gets closer to the sun. So the closer it gets to the sun, the faster that planet is going to move due to gravitational pull, right? So one thing I might add there that I didn't already write is this is due to gravitational pull. Okay, so let's add that just to make sure we get all the details ironed out, right? Okay, and then if we look currently again, 2, the farther a planet is from the sun, the longer its orbital time is. So for example, Mercury, a year on Mercury, the closest planet to the sun is 88 days, roughly 3 months. Whereas a year on Earth is 12 months, 365 days. And then you go to Neptune, you got the, go 100 plus years, 200 plus years all the way to Pluto, right? Which is a dwarf planet, not a planet. So, we talked about that. And then 3, perihelion is the closest point to the sun, as you can see in the picture below. Aphelion is the point farthest from the sun, okay, in that orbit. All right, table of contents, guys, same as last week. Go ahead and add 6 and 7 Newton's laws of motion. We're just going to talk about his first law today, Newton's first laws of motion. Newton's laws of motion. Our first practice question, guys, as I've said time and time again, sometimes I take these questions and directly put them on the quiz. So make sure you go over these, write these down, think about these. What shape do planets orbit the sun? What is the best answer? Is it A, circle, B, oval, C, cylinder, or D, ellipse? Correct answer, pause the video, think about it, is going to be D, ellipse, guys. Ellipse, again, it is like an oval shape, but your best, most specific answer was ellipse, Let's go. We did our questions of the day. Just something to think about, and I want you guys to write this down on page 7, which is going to be the difference. Question is turn and talk. No need to write this. No need to write the question out. What is the difference between speed, velocity, and acceleration? Speed, velocity versus acceleration. They all sound the same, right? But there's slight, small differences. Let's get into those with our first video of the day, which I'm going to post on Edsby as well. Oh, nope. Don't see that. Don't see that. You guys got it from me early. Okay. Got a little NFL example here. I'm just going to play a little bit of that's going to really explain those key differences between, again, speed and velocity and the like, right? Okay, 3, 2, 1. You guys can hear this okay?
Is his motion up the field as he tries to score.
Kinematics uses 3 concepts to define motion: position, velocity, and acceleration. Position defines location within a space.
I'm just trying to make sure the volume's okay, guys. 1 second.
Such as the surface of a football field.
Position would be a running back's location on the field, and he can change that with his motion.
In this play, let's define the running back's position where he takes the handoff. After executing the play, however, his new position is his opponent's end zone.
The position relative to the goal line changes the set of options that you're being shot out of a cannon.
Using McAllister's personal best in the 40, 4.26 seconds.
So, again, just to save us time on our video lesson,
is acceleration.
Responsibility for you guys to watch this video on your own, just to get those differences, kind of get the visual for those differences. Again, I don't want to just read something and then write it and then know it. You got to read it, write it, and see it, and then apply it, right? So I want you guys to make sure you hit on that. You guys get on that visual learning through those videos. So your answers after watching all of that together in class would have included, again, make sure to watch that on your own. And I should have started later, as it said there. Speed is the rate at which an object changes position. They mentioned position a little bit in the little snippet I just showed. It's the distance over time. So if I'm going north, south, east, west, that involves speed. Again, objects are not a direction, that's velocity, my bad. It's going to be just in which the rate in which it's changing position. So how fast is something changing position over time? Again, hence the unit miles per hour, right? Then velocity is what I mentioned earlier, which is the speed of an object in a given direction. So it's got to be, if it involves a certain direction, north, south, east, west, it's going to be velocity. So velocity is speed, just with a specific direction. Speed is just movement over a given period of time, okay? And then acceleration, rate at which an object's velocity changes, right? So the rate at which it's going to increase or kind of pan out and be more of at a steady pace, right? So that is acceleration. So they're all very similar. It all has to do with movement at a pace, but they're all with different circumstances. Speed is going to be the change over time with distance. Velocity is direction, and acceleration is the rate of change, right? Okay, again, that should all be on page 7. Keep that there for those notebook checks, guys. Okay, let's move on to some Newton's laws very briefly. I'm going to skip the Isaac Newton section. I want to talk about Newton's first law. You guys probably heard of these a little bit, but make sure to write these down, pause the video. Every object continues in a state of rest or a state of uniform motion in a straight line unless acted on by a force. So this involves inertia. Okay, resistance to change in motion of an object is related to its mass, right? So the key point is, guys, an object's going to remain at motion forever, or it's going to remain in a state where it's not moving forever unless acted on by a force. That force on Earth is what? If I roll, so for example, if I roll a soccer ball, right? I roll a soccer ball, it's going to move forever. But what force on Earth is acting on it that makes it eventually stop briefly after I start rolling it? It's gravity, right? Going to be gravity. Okay. Same with inertia. The heavier, the heavier, the more mass, right, an object has, okay, the more it's going to resist change in movement. So if I roll a bowling ball versus a basketball on field turf, okay, what's going to roll farther on the turf? What's going to roll farther on the grass? Probably the basketball, because it has less what? Less mass, right? So that is our first law of motion. Again, make sure to title page 7, Newton's laws of motion. Again, title page 7, Newton's laws of motion. As you saw up here, Newton's laws of motion. Title that on page 7, and this is your first law. Okay, so let's go ahead and take a look at a cool example of inertia that I will post Edsby as well. It's going to show a little quick snippet of this. Now we're going to see a water balloon here, and again, this is resistance to change. So you're going to see is a slow motion popping of a water balloon, and you'll see inertia in play here, because even though the water is immediately being released from the water balloon, you're going to see the water itself start to change shape, right? Start to change shape, but resist that change initially. We call that inertia. Let's go ahead and check that out here. You're going to see that on your own as well. Really cool stuff. So we see here inertia at what? Still resisting change, the ball of gravity. Gravity is acting upon it, which causes it to eventually lose its shape over time. Again, you can find and watch the whole video on Edsby on your own. Okay, let's go ahead and finish for the day here. I'm going to go ahead and just kind of skip along here. We'll get to force tomorrow a little bit. Last question today, guys. Which historical figure helped improve and make advancements with early astronomy equipment? Is it A, Tycho Brahe? Is it B, Galileo? C, Nicholas Copernicus? Or D, Johannes Kepler? Pause, think about it. This is kind of a throwback question from a week ago. Is going to be A, Tycho Brahe. Okay, last thing I want you guys to do actually is just go ahead and watch this last YouTube video. It is 45 minutes. Do not watch all of it. Given what we learned about Kepler's laws, I do want you to just write down 8 interesting facts. This would be at the end of class when we had extra time, right? I'm going to play as much as you like, 10, maybe 20 minutes of this, and just write down 8 interesting facts about the Kepler spacecraft. Again, this is the latest spacecraft that is being used to discover and analyze planets outside of our solar system. We call those exoplanets that may be Earth-like, right? So go ahead, watch that video. That can be found in Edsby as your last activity of the day. These 8 facts need to be written on page 6, and I will likely grade them for next week's notebook check. Okay, so guys, that concludes everything for today. Let's go ahead, why not, just show you a quick snippet of that clip as well for the last video. Again, all about discovering maybe planets that have other life forms outside of Earth, right? The Kepler spacecraft. I'm going to go ahead and just show you what you're going to look at it, because this is cool. This is cool stuff. I never try to show you guys ever stuff that is not interesting. I don't like boring videos, right? I want interesting, cool videos.
Because Kepler can't directly see planets. Planets are much smaller and dimmer than stars. They get lost in the glare. So Kepler is looking for something called a transit, which occurs when a planet passes in front of the star. As it does so,
okay, so this is going to be really good, really informative, and give you a really good kind of theatric view of the Kepler spacecraft. Just write 8 interesting facts, and you guys are all set for the lesson of the day. Okay, well, guys, that concludes our lesson today. I will try to get tomorrow's lesson ready. It'll be all set for you guys early in the morning. And again, do not forget, we've got another unit quiz Friday. We've got the lab analysis sheet that you need to complete by this weekend. And the quiz you will need to complete the quiz this weekend as well, but that will be open on Friday. Hope you guys are doing well. Staying on it, staying on track with your work. If you have any questions, feel free to message me. And I will see you guys again tomorrow. Mr. Campbell going ahead, and I'm going to sign out.